Polymorphism is another very important pillars of object-oriented programming. And poly means many, morphism means form. So it is essentially having many forms. In Java, polymorphism means the ability of a class to have different implementation for a particular method, and this can be achieved two ways. The first way is called method overloading, and the second way is called method overriding. Method overloading is also called compile time polymorphism, and method overriding is called runtime polymorphism. And when I walk through the overloading and overriding, it will be more clear why one is called compile time versus another is called runtime polymorphism. So method overloading, as the name suggests, it's overloading a method, meaning same method name with different parameters and or return times. So we can have a public void print name, and similarly we can have another method public void print name, but this time it can take a parameter called count. And once we do that, you can see compile time, there is no error. We have the same print name, but two implementation of that. So this is essentially what method overloading is. Now, if I get rid of this, you'll see that we have compile time error, and it says that duplicate method. And this is why this is also known as compile time polymorphism, because at compile time itself we would know there are multiple forms. Now if I just change here to return type to string, it is not going to work, because just changing return type does not make a method overloaded. It has to have parameters which needs to be different. So here again, let me add count, and the compile time error will be gone, and I have to return something here. So let's return an empty string. So the compile time error is gone. Now let's put it back as void. So this is essentially what method overloading is, and it is very straightforward. There is no complexity in terms of what it is. Now when it comes to method overloading, we can have multiple overloads. So for example, we can also have public void print name count. I cannot keep just count because it is same as the previous one. So we can have int count and let's say string address, and so on and so forth. So I can keep creating multiple forms. And for all of these, let's give system.out.println, and this one is no param, and the next one is going to be with param count, and the third one can be similarly with address count address. Let's say I'm making it pretty simple. And now if we go back to the main method of this hello world class, we can create an object of type user. And then here we can say user dot print. Then we can say user dot print with the count, and we can provide count as 0. And then we can use user dot print with count and address. So address here is null, so let's make the address is address. So let's go ahead and compile and run this. Run this now. We can see 3 output as expected. No param with param count, is equal to 0 with param count and address 0 and the address that we passed in. So this is all about method overloading, which is also known as compile time polymorphism. Now let's look into runtime polymorphism. So runtime polymorphism comes with method overriding. And when we talk about method overriding, it is always about having a base class and a child class. So let's say the user is a base class or a parent class, and we go ahead and we create manager, and the manager class here is going to extend user class. And now in manager, we can define the same methods as the user class. And when we do that, it is going to become an overriding because we are overriding the implementation of the base class in the child class. And this is what also known as runtime polymorphism. And why it is runtime polymorphism, you'll understand as soon as we go and try to access this method from the hello world class. So first let's declare this public void print name, and here we can do system dot out dot println, and we can say child class. And then similarly, I'm just going to go to the base class and copy paste these three methods here, and I can just put child with no param, child with no param. So this is how I can declare the three. And now what I can do is I can go ahead here and I can have user as an object. I can also have user as a type, call it manager is equal to new manager. And now I can do manager.print name and manager.print name of 0, manager.print name of 0 and address. I can compile and run this, and you can see here now I don't have a print ln here, so let's add the print ln so that it goes into the next line, otherwise it's pretty hard to read. Yeah, so now as you can see, the type of this implementation is declared as user, but we are pointing to an instance of manager. So, and when we call the print name at the runtime, the compiler knows that though the type of the manager is user, but since it is pointing to the object of type manager, it is picking up the implementation of print name from the manager class instead of the base user class. This is why it is called as runtime polymorphism. Now here, if I just change manager for one of them and put it as user, you can see that it is going to, of course, print out the user implementation, which is no param. Now we can have multiple child class if we want. For example, just like manager, we can create another class and it can be employee, and employee can extend user. And here I can just override one of the four print method. So I can just override this one and call it as employee child class. And let's go back here and I can create again user employee is equal to new employee. And then for the print name, I can do employee. For the print name of count of 0, I can use user, and the last one can be manager, just to show the runtime polymorphism at its best. And now we can see first one is printing out the employee child class, second one is printing out the base class, and third one is printing out the manager child class. So three of them is printing three different output based on what type of object the variable is pointing to. And this is what runtime polymorphism is all about. And this is another important pillar of object-oriented programming, which is polymorphism. So this is all I wanted to cover for today's video. If you like this video, please give it a thumbs up. And if you are new to this channel and if you think you are getting value out of this channel, please subscribe to the channel. And thanks so much for watching this video.